No designer working on a new plane would even consider that the aircraft might be in production for 30 years. Put simply, that does not happen. So, if that is the rule, there must be an exception. The Lockheed Starfighter's general specifications were nutted out in 1952, and it first flew in 1954. The last F-104 to be produced rolled off the assembly line in 1983. In the early 1950s, with the Korean War making new demands on US aircraft, the designers were confronted by a problem in the available engines. A new generation of engines was being developed, but these were still at very early stages, and the timetables for their availability were undetermined. Hence, the designers were uncertain whether to proceed with established, quite limited power plants, or wait for the new, lighter, and presumably more powerful projections. At Lockheed, the team led by Kelly Johnson, one of the best design groups in the world, was alternating between lightweight concepts built around the available jets or vastly heavier and more powerful designs based on projections of new engines. Johnson had joined the Lockheed company during the development of their Electra. He'd supervised some wind tunnel testing of the plane at the University of Michigan and had attracted the attention of Lockheed engineers with his constructive criticism of the plane. He was hired by the company, and it was his work on developing the Electra and the subsequent Hudson bomber into success stories that gave him a rapid rise. His innovative and intuitive work brought great reward for the company. The P-38, unorthodox, long-ranged, a pleasure to fly, was typical of his unblinkered approach to design solutions. It was a success as a plane and as a financial proposition, being manufactured in large numbers. The Lightning's twin boom can be seen as part of the pace and engineering daring of development in aviation during the 30s. However, with the end of the war, things got a lot quieter. Still with much activity around the new jet engines and in civil aviation, but with little of the pre-war impetus and only limited funding. In the USSR, unlike most post-war countries, design of new fighter planes continued at a great pace. A long series of new designs appeared, and though some of them were woefully inadequate, eventually Russia began to make very impressive military aircraft in large numbers. The popular Western perception of the Russians was that they lagged in design and industrial competence, and so the state of development of their planes came as a shock to many when MiG-15s appeared in the sky of Korea. The US pilots, hard-pressed in their sabres to keep on top of the MiGs, called for radical new planes to give them back the advantage that they had been encouraged to take for granted. Kelly Johnson, visiting Korea, repeatedly was told by the pilots that they needed a plane with the edge on the Russians in height and speed, and they needed it soon. That settled the debate on Lockheed's next project. Seeing the need as being a plane that would go as high as possible, as fast as possible, he determined on a lightweight fighter. In a short time, he settled on what was to be the 104's most controversial design element, its extraordinarily small, thin wing. This was a departure from most contemporary thinking. In addition to its size, the wing also disregarded the highly swept shapes that had been adopted for supersonic flight. Wind tunnel testing began on hundreds of variations around the basic concept. Much of the testing was directed at proving the wing, because of the many doubts being expressed about it. There were those who believed the wing could not be built to fly at all, those who did not believe it could be built to cope with super high-speed stresses, and those who thought that even if it could be built and cope with the speed, it would not be able to lift any worthwhile payload. It was to be only 7 foot long, and to go from being just over 4 inches thick at the fuselage down to under 2 inches thick at the tip. New boundary layer control was employed to allow the tiny area enough lift for a short landing length, but it would have no internal provision at all for guns or wheels. Many elements of the design were studied during the supersonic wind tunnel testing. Here, attention is focused on the air intakes, seeking to prove that the shock waves round the inlets allowed for controllable and dependable supply to the engines. This footage, taken near Mach 2, shows the shock waves around the model in tests to establish the pressure loads in the ducting under various flight conditions. In addition to the wind tunnel testing of the 104, more unconventionally, the design was further tested as models bolted to 5-inch Army rockets and shot off over the desert. These tests reproduced fairly accurately the types of stresses that very high speeds and accelerations would exert on the wing at lower altitudes. Not only did they allow for testing of the shape of the wing, but also its construction. Though apparently eccentric, the rocket firings were a very valuable tool for the engineering team. Tests on the tail were also conducted. It too was designed to be very thin, and there were many people unconvinced that it could be given enough strength. Once again, the tests helped the team to sort out the best combination. In a short development period, hundreds of models were built as the basic elements were shuffled. Generally, little or nothing was added to the original plane. And with the F-104's appearance settled, a contract was issued for 2 planes to be built. The first step in the fabrication saw the 3 fuselage modules mocked up in full scale. Simultaneously, the jigs to cradle the whole planes were built. All over the workshop, drilling, milling and cutting of the parts commenced. The planes, on an experimental production run, were essentially hand-built. In a flurry of activity after the receipt of the March 1953 contract, Lockheed cleared production space, constructed a wooden mock-up, and then, without stopping, built the 2 prototypes. The first flight was to take place only 12 months after the signature of the contract. The achievement in that 12 months is astonishing. This was not a design that had been simmering away on the back burner for a long time. It had come into existence in late 1952. It was a leap forward in aviation and technologically very advanced. However, its development was spectacularly rapid. The controversial wings were not made to go through the fuselage, as with most of the fighters of the day. They were bolted to the side with heavy-duty precision-forged aluminium fittings that tied into the wing skins. What Johnson had designed was very straightforward in some ways. Asked for a plane that could fly higher and faster than the MiGs, he'd produced a manned missile. With its undercarriage retracting into the fuselage in a fairly complicated way, even this had to be subjected to more than the usual testing. The Air Force had had no legal document calling for submission of a design anything like the 104. And without the prestige of Lockheed and Kelly-Johnson, they may have simply rejected it. However, given the claims of expected performance, finding the concept logical and exciting, and with no other way to really assess the idea, they had issued the March 1953 contract. There was still no apparent existing slot in the inventory for such a plane, but there was also the evidence of Korea to suggest that perhaps there should be. The F-104 was, however, very definitely on trial. The construction of the plane went ahead rapidly, with the major sub-assemblies coming together and vibration testing at Lockheed's plant. The vibration testing established the natural frequency patterns for the entire structure in final preparations to ensure the plane was safe for flight. The F-104 prototype left the Lockheed plant in the early morning of February the 25th, 1954, amid tight security, and was transported to Edwards Air Force Base. The crews immediately began a thorough round of checking and rechecking the plane's systems in preparation for its first flight. The engine selected for the prototypes was the Wright J65, which was to prove very inadequate in propelling the 104, neat and light though it was. Most production starfighters were to use the General Electric J79 engine, with higher thrust and less weight. It was this engine that was to send the 104 beyond twice the speed of sound. With the first flight a few days off, the rapid tempo of testing continued, with the engine being run up and finally prepared. For a number of reasons, including the fear of ejecting pilots being dismembered by the tail of the plane, the seat ejection was arranged to work downward. While obviously of no use at low levels, this system allowed for a simplified layout in the cockpit and the arrangement of the canopy and the seat itself. Because of the danger of impacting pilots straight into the ground, later starfighters used conventional ejection seats, firing upward. Although the test pilot Tony Levere had made a skip-off during taxi trials on the 28th of February, on March the 4th, 1954, the 104 was rolled out for its first official flight. Levere ran through a series of ground tests, operating the flight controls and checking that everything was working. Satisfied that all was well, he then started down the runway and lifted the 104 into the air for the first time. In the weeks of test flights that followed, it became evident that the power plant was lagging far behind the Mach 2 potential of the airframe. But the Lockheed concept of the lightweight fighter was conclusively proved. Despite the prototype's inability to exceed 1.3 times the speed of sound with its current engine, the design had been vindicated sufficiently for the Air Force to order 15 more planes with uprated power plants as F-104As. In April 1955, one of these finally took the Starfighter past Mach 2, which was the signal for 104 production to swing into top gear. For the moment, the intense testing of the two prototypes continued. The prototypes, seen here flying together, were both to be lost in accidents during the test period, which was long and troubled. There were many incidents where bugs in the plane's engine or its other equipment were encountered, often in situations that were either potentially or actually very dangerous. Tony LeVere was involved in one early mishap in 1955 while testing the firing of the Starfighter's high-speed cannon in supersonic flight. After a trouble-free first firing, LeVere started the plane on another run, ready to fire the gun again. This time, something went dreadfully wrong, and the plane lost all engine power. LeVere found himself having to make some very quick decisions. He was about 40 miles from base, but high enough theoretically to be able to glide back to land. This is what he set out to do, knowing that he still had a margin to eject from the plane, but also knowing that very soon he would have to commit himself to the landing as he passed below the safe limits for the ejection seat. Even before the hatch was opened, a dirty smudge of smoke showing on the fuselage confirmed that the gun had caused the trouble. Behind the gun, in the gun compartment, was a hole blown into the plane when a cartridge had ejected backward through the gun baseplate. Relieved that the malfunction was in the gun and not in the airframe, the engineers fixed the plane and the tests went on. The repaired prototype, number 787, went back to the gun testing, but 4 months later there was to be a recurrence of problems with the cannon. With pilot Herman Salmon at the controls, the 104 leveled out at 47,000 feet for its second firing run of the day. Again, there was an explosion, but this time the damage was major and the aircraft became uncontrollable. At 20,000 feet, the pilot ejected from the crippled plane. Emergency services responded immediately, and Salmon was located, fortunately unharmed. The Starfighter was a total loss, the first of many F-104s to be written off in crashes. The cannon had been the obvious suspect in the crash, and it was established that again a malfunction in the gun had damaged the plane, this time with drastic effect. The Starfighter's gun was the Vulcan M61 cannon. 6 foot long and 300 pounds in weight, it was, at the time, claimed to be the fastest firing gun of its type in the world. It could fire 6,000 20mm cannon shells in a minute. The design borrowed two features from the famous Gatling gun, first patented way back in 1862. Both had a rotating cluster of barrels and both were externally driven. Rigidly clamped together, the 6 barrels gave each other support and the installation did not have the whip of a single barrel. In addition, the arrangement centralized the recoil of the gun. In contrast to the hand-cranked Civil War Gatling guns, the M61 was driven with electric power from the plane. This did away with any need to attempt to trap and use the exhaust of the gun firing, which meant that the installation was less susceptible to corrosion or fouling. Each round was fired independently, eliminating the erratic recoil of multi-gun and gas-reloaded options. At the time, the M61 was a new weapon, and the troubles that it caused in the early days of the 104 must be accepted as part of the teething that can be expected with any piece of advanced equipment. A comparison of the Vulcan with the US Air Force's previous preference of machine guns is difficult. In hitting power, range, speed of fire, the effects of the plane on the gun's action, indeed all measures of effectiveness, the Vulcan has such a wide margin of superiority as to render such an evaluation meaningless, even with consideration of multiple machine gun installations. Contrasting with Kelly Johnson's assessment, the military procurement policies after Korea demanded multi-role capability. So, despite the origins of the design as a single-function specialized fighter, provision was developed for the F-104 to carry a mix of weapons. Though the Starfighter's superlative performance was appreciated in the USAF, it was not seen as sufficient justification for the project, and Lockheed was forced to develop some unlikely attachments for the plane in trying to convince the Air Force to stay with the project. Among these was this trapeze installation to allow the carriage and delivery of the Genie nuclear rocket. This clever launching mechanism was another product of Kelly Johnson's intuition. Put the challenge that his plane could not deliver the device over a combat radius of 650 miles, Johnson undertook to have it do just that within 60 days. The tiny Starfighter's fuselage was already fully occupied, and a major influence on the launcher was the need to keep it out of the way of the undercarriage. With little fuss, the 104 demonstrated successful firings of the Genie at 56,000 feet at above 1.7 times the speed of sound. But the ability of the design to respond to such a challenge was to serve it little good in the Air Force's eventual assessment. Lockheed tested a variety of weapons delivery attachments and external fuel tanks, increasing the range and versatility of the plane, but still could not rescue the project. The weight of opinion against it was gaining momentum. The 104 was very much in the right place at the wrong time. It affronted most of the prevailing trends in design. Where other fighters were getting bigger to do more things, Kelly-Johnson had abandoned all but the essential ingredients in getting the plane's size down to get Mach 2 out of a single afterburning turbojet. But this condemned the Starfighter to a very limited career with the USAF. There was simply no way to cram all the rapidly expanding hardware of radars, aiming controls and other new avionics into the little plane. Its capabilities were not to be matched for many years, if they've ever been effectively matched. But the fact that it could do a lot of things that its heavy brethren could not do was ignored in the overall antipathy towards lightweight fighters. It lacked all-weather capability, lifting power and range, the assessments said, and these perceived failings were eventually to decide the issue. The project was set for financial failure, but the work that had started on giving the F-104 greater versatility went on apace, trying to forestall the inevitable and keep the Air Force involved in the plane. The plane's weapons capability included standard systems like the Sidewinder air-to-air missile. There was no question that it was an effective firing platform. The little plane revelled in the air superiority role it had been built for and was, stiletto-like, lethal. More sophisticated radar and fire control packages were developed for the fighter, and prowling B-47 bombers were detected and intercepted with great efficiency. But the Air Force was fully aware of the fighter's capabilities and preferred other options. From the start, the Air Force attitude had been guarded. The F-104 was the first plane to be purchased on a fix-then-fly basis. To that time, the practice had been for the Air Force to accept a new plane into use while it was still being tested, and to conduct a large part of the testing itself, the fly and then fix principle. With the radical nature of the 104, the onus was returned to the manufacturer, and this has since been the rule. The complexity of the packages that modern combat aircraft have become allows no other avenue. As the prospect of large USAF orders faded, another market was quietly revealing itself in Europe. The pure performance of the plane was remarkable, and with its rapidly expanding tactical capability, it was maintaining a position as the design to beat. On top of the expansion in the weaponry of the plane, during 1958 and 1959, it was sent on a spree of record-setting to reinforce the message of its potency. Even when the new F-4 Phantom II broke some of the Starfighter's records, the F-104s promptly set new marks outside the F-4's ability. Essential to the Starfighter in overcoming criticism of its limited range was that it accommodate in-flight refueling technology. At the time, this was still very new, and expensive lengths were gone to in setting the plane up. The 104 had to display capacities in ordnance, range, and technical sophistication that had been deliberately excluded from the designer's original consideration. These were now deliberately reworked into the performance spectrum to prepare for the potential specifications to be set by the West German Luftwaffe. To be able to sell the planes in large numbers still required overcoming the same problems that the USAF had set. It had to be developed into a multi-role all-weather strike aircraft. And, with question marks already over the plane, it had to compensate by not simply succeeding, but excelling in the tasks it was set. Even so apparently simple a task as aerial refueling. The German order was becoming so important as to require all sorts of unlikely capacities from the plane, including barrier landing strength, the Luftwaffe being concerned to be able to deploy planes away from bases in the event of conflict. The plane displayed that it had the strength to cope with this artificially shortened landing, but the challenge to the pilots was another thing entirely. In the long term, there were to be few performance targets set for the F-104 that it could not cope with. But there was never a certainty that any individual pilot would be able to cope with the plane. The need for specific training of pilots for the F-104 was a signal of things to come, rather than an exception to a long-standing rule. A properly trained pilot flying a well-maintained 104 was not at risk, but when an unprepared pilot met the plane, the combination could be lethal. The Starfighter's survival had become dependent upon sales in overseas markets, and the development of the plane became determined by the specified and perceived needs of the NATO clients. If Germany needed short takeoff and landing, then Lockheed would show successful crash barrier landings and zero-length launch capability. Here, on the first occasion that such technology was tested, the truck-mounted rocket-propelled launch system is demonstrated with an F-84. First unmanned and then with a pilot, the launches were executed satisfactorily. Nothing very useful was to come of this development, but the potential for its successful employment with the Starfighter was a valuable string to the project's bow in the eyes of the Luftwaffe. With West Germany being the border between Eastern and Western spheres of influence, it was essential that no less than the other European states she retrieve her power as a military force, not only in weaponry, but in industrial capacity. Unlike the situation at the end of the First World War, there was a perception of a need for a strong Germany at the front of the Western Alliance. Germany's logical concerns became considerations for the company strategists working on selling the 104. The concentration on Germany's conceivable needs was reasonable. NATO needed new arms, and there was a healthy desire to standardize the NATO armories. If the German call for new equipment could be won for Lockheed, the signs were that many other orders would be won at the same time. The nearest the Starfighter was to get to a regular use of rocket-assisted takeoffs was with the specially built 104Ns, which employed rocket firings in exposing potential astronauts to operating hydrogen peroxide thrust controls in the thin air over 100,000 feet. One of the developments that saw the F-104 concept saved was the two-seat variant. US fighters always seemed to have a trainer or reconnaissance version that used two seats, and the F-104 was no exception. The Germans were primarily after a ground strike aircraft, but also were looking for a jack of all trades, and a twin-seat variant was very much part of their thinking. Lockheed's sales strategy included a production offset package that would see the planes manufactured by cartels of European aviation companies. The shot in the arm for European aerospace capability from the construction of these new factories was one of the clinching factors in the successful campaign. The plane itself performed very well. In the fly-offs, its edge over the other entrance was clear, to the point of almost being a walkover. The competition for the contract was serious, and some of the competitors were very able aeroplanes, particularly the British Lightning. But it would appear to have been sabotaged by political considerations, and by the time that the contract was decided, the 104 had proved itself the outstanding aircraft in the competition. The development period had been long and plagued by various troubles, and the plane's reputation as a hot ship had cut a bit both ways, in that its unquestioned performance could be very unforgiving to the unwary pilot. There were constraints on what a pilot could get away with in his 104. There were to be over 8,000 flights in the test series using 52 aircraft, and several of the planes were lost through equipment malfunctions and pilot errors. That the Starfighter arrived near the junction between two ages of aviation meant that its technology was virtually all new and untried. This meeting of the two ages is almost comically embodied in this sight of the 104's trim nose bolted to the front of a DC-3 during testing of the Starfighter's avionics. The plane was not the first US design to seek lightweight and smallness as virtues. For example, the Bell XP-77 had nearly gone into production during the Second World War. The wing, too, was not without precedent, being very similar to that of the X-3. But the Starfighter was revolutionary in many ways, and as the program went on, it was surrounded by controversy, much of it not centered on the airframe, but sufficient for the Starfighter to be unfairly dismissed as a lemon. The USAF pulled its 104s out of operational use after only 2 years of service, though later, during Vietnam, some were to be deployed in Southeast Asia as high-flying MiG-cap for the B-52s and in low-level tactical support strikes. The Russians had also learnt lessons from Korea and the experience there of their redoubtable MiG-15s, and had developed the MiG-17. Where the Starfighter sacrificed almost all in the quest for speed and climb, the USSR developed a radically different requirement, issued in 1953. This was for a short-range interception fighter. High performance was stipulated, especially in speed, climb rate, and rate of turn. The primary armament was to consist of air-to-air missiles, internal cannon, and a light ground support bomb load. The MiG-17s were basically an updated 15, with better handling and a more sharply swept wing and tailplane. It was to be built in very large numbers, and though theoretically obsolete even when first proposed, it defied this assessment and proved a very valuable and effective plane, even in the mid-60s in the skies of Vietnam. US thinking was totally different. If we ignore the F-104 and look at the other Century fighters, we find that they all were much larger planes. They also shared a commitment to state-of-the-art technology with varying degrees of success. The 100 Super Sabre, the 101 Voodoo, and the 102-106 Delta Dagger Delta Dart all faded fairly rapidly into history, seeing limited service in Vietnam. They all reflected in their way the concept of the fighter as a standoff missile launch platform. Theoretically, they were specialized aircraft, devoted to facets of an overall fighter spectrum. But during their careers, these divisions tended to fade, as each developed multi-role capacity. The 100 and 101 in particular grew into different uses. It is doubtful that any of the other planes in the Century series could have coped with the Starfighter as an opponent. Indeed, there are many considerably more modern planes that would have great difficulty with 104. The overseas sales program with the Starfighter not only rescued the project from the brink of financial disaster, but made it into an outstanding success for the company. With the deals on production, it went into service with 14 air forces and was the nearest to a standard Western fighter plane to have been achieved. The fire control systems and other controls were virtually tailor-made for each country's version of the plane, and it came to be used in many ways. The 104 may have had a reputation for demanding the respect and care of the pilot, but it also had a reputation as the hottest thing in the air. The customer air forces around the world employed it in a variety of roles and persisted with its development throughout the years that followed, right down to the last ones, built in 1983. As presumably everybody knows, the Germans, whose order had been so critical, initially had a fairly miserable time with the plane, losing over 200 of them in accidents. The reasons for this are many, but little blame can be apportioned to the plane itself. The disaster of its early deployment with the Luftwaffe had complex roots, and it took time to rectify the causes. The West Germans had a shorter, similar experience when bringing the F-4 into their inventory, and none of the other Starfighter customer nations had an experience remotely like the German problems. It is safe to say that these problems sprang in the main from the Luftwaffe's circumstances at the time. Lockheed maintained its own private Starfighter as a promotional device, flying almost constantly round the world in search of orders, and in later PR efforts to try to rescue the plane from the snowballing bad publicity that was attaching to it and turning it into possibly the most controversial aircraft of all time. It was in this plane that Jackie Cochran, the hero of the 30s Bendix races and the Second World War Wasps, the women ferry pilots, became the first female Western pilot to break the speed of sound. Kelly Johnson's design team proceeded from a plane with almost no wing to a plane with extraordinarily long wings, the U-2 spy planes, and then to the remarkable Mach 3 SR-71 Blackbird. Both of these aircraft bear some superficial resemblances to the 104. Certainly, comparing the three to other planes of their time, it's easy to see them as stablemates, products of the one vision. The man behind these planes, Kelly Johnson, retired, universally respected as one of the giants of aviation. His designs over his long career having constantly been at the cutting edge of their time, and some far ahead of their time. The 104, redesigned with bigger wings and greater maneuverability as the Lancer, was put forward in the fighter competition that saw the F-15 come into mass production. The proposal would appear to have not been taken very seriously, and no Lancers were built. Johnson maintained that the Lancer would have run rings around the F-15, and there is a considerable body of opinion that agrees with him, that even suggests that, in an aerial combat, the Starfighter itself might give the F-15 trouble. The problems of the 104, right from the unavailability of powerful enough engines for the prototypes, and then the unreliability of the J-79 when it did become available, had continued throughout its early career. The testing scrutiny of the plane had been without precedent, and the methods and technology of such testing has never been the same since. The development phase had seen some major troubles, like the problem of pitch-up, overcome in a test process that refined the ideas relentlessly and polished the plane into a powerful and reliable, though still eager, skittish and restive weapon. Despite being saddled throughout its lifetime with an odious reputation and seemingly never being free of controversy, the 104 vindicated the decisions of its creators. In its long career, it has carved its own very special place in the story of aviation.